Continuing with section 5 of chapter 1, we have got examples regarding those properties of limits involving infinity. Let's see how can we solve limits when the x is approaching to infinity or negative infinity. So far what we have studied those limits that the x is approaching to a proper number, to a number, okay? If it is negative, positive, it doesn't make a difference. We were solving it, it was easy. How about if you have got x is approaching to infinity or negative infinity? The example that we have got, we've got example 1.5.7. It's required from you to find the limit of x as is approaching to infinity. Look, the x is approaching to infinity here. We have to solve it, of x squared over 1 plus x plus 2x squared. Okay, how do we deal with that one? Previously we were putting the number that was given to us here in both numerator and denominator, but here if you put infinity in here and there, what will we get? We will get infinity over infinity. Infinity over infinity is something indeterminate. We cannot solve it. There is no solution for that. I mean, we cannot solve it in general. There are methods for solving it. So what shall we do? We have to find a solution for that one. We have to find a method for finding that solution. To do that one, we first look at the denominator of the function that is given to us here. So if a rational function is given to us, we are pick, okay, the highest power of denominator. Look, that's important because students are always making mistakes. I just want the highest power of denominator, not numerator. I don't care if that power is 10 and that one is 2. I'll pick the 2, okay, not the power 10. Whatever is in the denominator, I'm looking for it and I'm picking the highest power. Now, as we said, we don't care about numerator. What is the highest power of denominator here? Okay, I will write it for you. Highest power is 2. So I have got x squared. Okay, I have got that x squared. That's the highest power of the denominator. The second step is to divide both. Okay, we have to write both numerator and denominator by highest power. Okay, highest power of denominator. So what was the highest power of denominator? It was x squared. Now what are we gonna do? Limit of x as is approaching to infinity. I have got x squared. I will write it for you all. 1 plus x plus 2x squared. What will I do? I will divide both numerator and denominator by the highest power. The highest power was x squared, so I will divide each term by x squared. Okay, every term by x squared. What will I get from the result? I will get limit of x as this approaching to infinity. X squared over x squared is equal to 1. 1 over x squared, I cannot make any sense here. I cannot make any calculation or simplification here, so I will write it as it is. Plus x over x squared is 1 over x, okay, because 1x goes with 1x. And then we have got 2x squared over x squared. X squared goes with x squared, so 2 is remained in here, okay. Now let's do the calculation. What have we done so far? We know that the limit as x is approaching to infinity is different from the numbers. We cannot directly input it from in both numerator and denominator. So what are we gonna do? We are going to pick the highest power in the denominator and then divide all of the function that I have got by that highest power, and then simplify it. Of course, you can do all those steps together, but here it's for clarification. I will not skip this, the steps. If you look at this one, limit of 1 is equal to what? Is equal to 1. Limit of 1 over x squared, if you remember, I think it was, no, it was here. Limit of 1 over x squared, if x squared is in the denominator and x is approaching to infinity or negative infinity, what is that result? That result is 0. That result is 0. 1 over x, limit is x approaching to infinity, so the result is 0. So what is that calculation equal to? Of course, limit of 1, it's a constant number, is equal to 1, and limit of 2 is equal to 2 for x approaching to any number. So what is that result equal to? That's equal to 1 over 0 plus 0 plus 2, that's equal to 1 over 2. Okay? So that's how we solve, how we deal with limits of x is approaching to infinity or negative infinity. If I change that example with negative infinity, I would do the same procedure. Okay, so if it was x approaching to negative infinity, I would again pick the highest power of the denominator and divide everything by x squared, and then we'll get the result that we have got. Okay, let's move to the other example. Example 1.5.8. Again, it's required from us to find the limit of x approaching to positive infinity. Again, I said even if it is negative infinity, we are doing the same procedure, okay, for finding the limit of infinity. Come on, what have I written? That's 3x all over 3x squared minus 5x plus 2. That's x. Again, we are looking at the denominator. What's the highest power of denominator? I'm looking at here. The highest power is x squared. So I'm dividing all of the procedure by x squared. So that one is equal to limit of x as it is approaching to infinity. Let me write this one first. 3x squared minus 5x plus 2. We are dividing all by what? We are dividing all by x squared. Okay, why x squared? Because x squared here is the highest power of the denominator. So we are dividing all of the terms by x squared. Now what will I get from this one? 2x squared over x squared will equal to 2 plus 3x over x squared. X goes with x squared, so 3 over x remains here, plus 8 over x squared, no cancellation, all over 3, okay, because that one goes with that, minus 5 over x plus 2 over x squared. And of course I have got, let me write it like that, limit of x as this approaching to infinity. I forgot to write it here, so this one belongs to here. Okay, now we are inputting infinity into that function. Because we did the calculation, now I have to see what happens when x is approaching to infinity. If x is approaching to infinity for 2, it's equal to 2. For 3 over x, by the previous limit involving, what did I say? By this one, okay, limits involving infinity, it's equal to 0. 8 over x squared, this one is again equal to 0 as x is approaching to infinity. 2 over x squared is equal to 0 as x is approaching to infinity, because this one distributes all over all of them. That's why we are calculating it like that. And limit of 3 as x is approaching to infinity is equal to 3. So what is that result equal to? 2 plus 0 over 3 minus 0 minus 0. So that's 2 over 3. Okay, so for limits involving infinity or negative infinity, how can we solve it? We are first checking the denominator, finding the highest power, and then divide all of the terms that we have got by the highest power of the denominator, then solving it like that, distributing the limit over the parts, we will get the required result. We've got another example, 1.5.10. It's required from us to find the limit of x as this approaching to infinity of minus x to the power of 3 minus 2x plus 1 all over x minus 3. If you look at this one, again we have got x is approaching to infinity. So what's the method for solving it? To check the highest power of the denominator. What is the highest power of the denominator? It is x. Okay, so x is the highest power. Look, even though I have got x to the power of 3 in the numerator, but I don't care about it because we said we care just about the denominator. So let's solve this one. That's equal to limit of x as it is approaching to infinity minus x to the power of 3 minus 2x plus 1 all over x minus 3. Now we are dividing all of the terms by what? By x to the power, x alone. That's divided by x, divide by x, all of them divide by x. What's the result of that? That's equal to limit of x as it is approaching to infinity. Please do not forget that limit here, as I forgot it here. Minus x cubed over x, that's equal to what? Minus x squared. Okay, because 1x goes with 1x, so x squared is remained. Minus 2x over x, those x's cancel each other, so minus 2 remains here, plus 1 over x. Okay, now for the denominator I have got 1 minus 3 over x. Okay, since so far we have done the simplification and we got this one. Now let me see if I put infinity into those terms, what will I get? If I put infinity into that term, I will get infinity. If I put it into this one, I will get 2. If I put it into this one, I will get 0. For this one, limit of this one is equal to 1, and limit of 3 over x is equal to 0. Let's calculate it. That will become minus infinity minus 2. If I take minus 2 from infinity, will it make a difference? Infinity is a very large number. Even if you take 2 from it, it's still infinity. So that will be minus infinity plus 0, okay, over 1 minus 0. So that would be minus infinity over, or let me write it like that, minus infinity minus 2 plus 0 over 1 minus 0, so that you can see the result better. So that's equal to what? Minus infinity minus 2 plus 0, that's equal to minus infinity. Okay, if I take 2 from infinity, nothing makes a difference, and infinity over 1, that's equal to minus infinity. When we get the result is infinity or negative infinity, these ones are called infinite limits. Okay, the name is called infinite limits, although it's not important to know the name of the limit, because it's the important for me is that the important thing is here is the result. Okay, what will I get if the x is approaching infinity or negative infinity? Sometimes I would get numbers, okay, sometimes I would get infinity or negative infinity, which is called infinite limits, and sometimes I would get 0. Okay, so I have got 3 cases. Either I'm getting a number out, okay, or I'm getting infinity or negative infinity as a result of solving it. Of course, I have got limits may also equal to 0, as I will illustrate it with an example a little bit later. And of course, the limit may not exist. So let me give you an example that's not in your book. Okay, I will illustrate the case where the result of the limit as x is approaching to infinity is equal to 0. If I have got x minus 3 over x squared plus 2. Okay, let's solve this one. What's the highest power of the denominator? Highest power is x squared. Look, I do not look at the numerator, I just care about the denominator. So that one is equal to limit of x as it is approaching to negative infinity of x minus 3 over x squared plus 2. So we are dividing all of the terms by x squared, x squared, x squared, and x squared. What's the result? That will equal to limit of x as it is approaching to negative infinity. X over x squared is equal to 1 over x, okay, minus 3 over x squared, okay, because this one is not simplified more, and that one 1x goes. X squared over x squared is equal to 1 plus 2 over x squared. Now if you put infinity, negative infinity into here, what will I get? 1 over x, as x is approaching to infinity or negative infinity is equal to 0. That one is equal to 0. That one is equal to 1. And that one is equal to 0, 2 over x squared. How this one's got, I got those results? By inputting infinity into each one of them. Okay, so it is the evaluation of the limit. So now what will I get? I will get 0 minus 0 over 1 plus 0. 0 minus 0 is 0. 0 over 1 is equal to 0. So the three cases here, that if I have got, I will get a number, I'll get infinity or negative infinity, and I will get 0. In general, you have studied limits as tricks. You have studied that if the power of numerator and denominator are the same, if you look at this one, the power of the numerator and denominator are the same, so the result will equal to their coefficients 1 over 2. But when you are writing it the short way, you have to write the reason for me if you're not doing those steps for me. Or we have got another case, if the power of numerator is greater than the denominator, the result is either infinity or negative infinity. But you have to solve it to see whether it's infinity or negative infinity, because you cannot determine it just like that. If the power, the third case, if the power of numerator is less than denominator, the result is always 0. Okay, but you have to write the cases for me, the causes for me. If you're just writing that the result of this one equal to 0, if there is no cause written next to it, you will definitely lose marks on that, because I want everything written step by step and with their causes, of course. That's all about the limits of section 5. We studied limits of x approaching to a number, okay, for a function of f of x. We said we can generally solve those kinds of questions as x is approaching to a number. We could factorize them and get a result, removing the number from the domain of the function. We had limits involving infinity, x approaching to infinity or negative infinity, and we are using another method for finding those kinds of limits. That's all about that section. In general, we said limits are approaching to a number. We are checking the behavior, okay? We are checking the behavior of the function near x approaching to that number, near that number, but it's different from f of a number, okay? So those two are different in general. They are not always giving us the same result. That's all about that section. That was about limits. I hope you would understand the video when you're watching. Have a nice time and goodbye.